Hello, I'm Kate Medlicott, Technical Officer for Sanitation and Wastewater at the World Health Organization. In this video, I will give you an overview of sanitation safety planning and we'll look at an example. Sanitation safety planning, or SSP for short, is a risk-based management tool for sanitation systems. A safely managed sanitation system prevents exposure to disease-causing excreta at all steps of the sanitation chain, from containment through emptying, transport, treatment, and to disposal or reuse. It can be used together with excreta flow diagrams, or SFDs, shown in the previous module, to make sure that excreta reaches safe rather than unsafe endpoints. SSP reduces health impacts while increasing the benefits of reuse. SSP can be used for all kinds of sanitation systems, both in formal and informal settings. The approach is best used for improving existing systems. In communities with no sanitation, demand creation should be prioritised. So how do SSPs work? First, we need to understand the system we plan to manage. This is referred to as a system assessment phase, where the sanitation chain and exposure groups and pathways are identified and expressed as hazards. Risks are assessed, and when they are unacceptable, improvements are designed to reduce them. This approach ensures action is prioritised according to risk. Monitoring and management using multiple barriers along the chain ensure that the whole system is operating as intended. SSP can be applied in many settings. Today I'll be illustrating the approach in an informal urban setting typical of growing cities in many countries. We'll follow the chain showing examples of exposure groups, hazards, controls and monitoring at each step to build up a safely managed sanitation system that protects public health. Notice as we go that not all improvements involve expensive capital investment. Changes in management and behaviour can also significantly reduce risks. Also notice that different stakeholders bear responsibility for controls and monitoring at each step. Here is a simple pit latrine with manual emptying. Although excreta are contained in the latrine, this unimproved system poses a number of health risks. Exposure groups include the users, the workers who empty the containers, and the surrounding community. Children and the elderly are especially vulnerable from contact with soiled surfaces in an unhygienic latrine. These groups may be exposed via direct excreta contact through the feet and hands, and when excreta is inadvertently transferred to the mouth via dirty hands or flies. The risks here are medium to high, depending on the exposure group. While the goal is a more hygienic, improved sanitation technology, we can still reduce risks. For example, controls such as wearing shoes, better cleaning of the latrine, personal protective equipment for workers, and using an emptying system that reduces direct contact will all incrementally improve the system. Visual monitoring of these measures by a community health worker is a simple way to check and respond if these controls are not in place. This latrine with septic tank is an improved technology that poses less risk to users than the previous situation. Let's look at the emptying process. Motorised emptying and transport is much safer than manual emptying, but there is still risk that need to be managed. A key exposure group is the workers. Hazardous events are mostly related to blockages and malfunction of the equipment. For example, the operators may be sprayed with sludge and also contaminate the surrounding area. These risks are typically high. Here are some controls to protect workers: providing appropriate equipment, working according to standard operating procedures, and ensuring workers wear personal protective equipment. The organisation responsible for overseeing collection and transport can set minimum standards like these and make spot checks to monitor if they are followed. In this example, all of the fecal sludge is delivered to the treatment plant, but in poorly managed systems, some may be diverted to dumping sites. This can have serious health and environmental impacts. SSP should also identify dumping as a hazardous event and include controls and monitoring to manage these risks posed to the wider community. At the treatment step, it is vital that the treatment process operates well so that effluent and biosolids meet agreed standards. If not, users on farms and consumers of the farm produce will be exposed to an unacceptable risk. The hazardous events may include overloading of the plant, breakdowns, the processing temperature and time, and the presence of flies or mosquitoes, or seasonal factors such as high rainfall that may affect performance. The risks and consequences of these are high. Example controls include proper design and construction, trained operators, and a preventive maintenance program. Monitoring may include periodic testing of effluent and checks on delivery volumes. But even the best treatment processes will occasionally not meet standards. In some cases, lower levels of treatment may be unavoidable with the existing technology or desired by farmers who wish to access nutrients for reuse. That's why barriers at the next reuse step are particularly important. During reuse, there are risks to farmers using the biosolids, especially where intestinal worm infections are prevalent. Risks will depend on the performance of the treatment plant in the previous step and the way the biosolids are applied in the farm, for example, manual or mechanical application. When produce is sold to the general population for consumption, many people are potentially at risk. Pathogens can be recycled back to the community at large and lead to a disease outbreak. This is costly in terms of public health, but it can also ruin the reputation and operation of businesses that reuse wastewater and sludge. The type of crop grown and the application method affects the risk for consumers. For example, crops eaten raw have a much higher risk compared with crops which are cooked or processed before eating. These risks are potentially high. Controls that can be used include selection of crops not eaten raw, setting a time between the last application and harvesting to allow pathogens to die off naturally, and washing of produce in clean water before sale. Monitoring may include checking crop types, application and harvesting practice, as well as hygiene during the packing and sale. We have just followed the modules in the SSP manual. First, describing the sanitation system, identifying hazardous events and exposure risks, developing and implementing improvement plans, monitoring controls and verifying performance. Coordination amongst stakeholders is needed to implement all controls and monitoring in a safely managed system. That's why establishing a team at the outset with members representing each step of the chain is vital to prepare for SSP. Coordination can be challenging, but evidence shows that safely managed systems lead to far higher health gains than improved sanitation alone. Further, using the multi-barrier approach reduces dependence on capital-intensive treatment technologies as the main barrier. Controls can be included at any step and incrementally improved over time as resources permit. In summary, SSP is a risk-based tool for safely managing existing sanitation systems. SSP coordinates improvements and monitoring by actors along the sanitation chain. SSP does not rely on treatment only. It uses multiple barriers, including behaviours, management and technology to prevent exposure. The SSP manual that includes more guidance and tips is available in several languages on the WHO website, along with other resources to help users get started and implement SSP.